whatever it is, wherever you are. We've made some progress in our refactoring, but I'm still not super happy with the HTTP request interface. Ah. I'm trying to remember if Toronto was the one that I went to a long, long time ago. It was a Ruby conference in one of the nearby Canadian cities. I remember. I went through Detroit area, I think. So over on the Great Lakes side. Okay. Those are the problem with taking long breaks. So a very thin model. We got some of the stuff of the event response. I do freelance software development. So at the moment, that is mostly working on some stuff for a e-commerce site. The company I'm working with is adding some like CMS support stuff. Okay. Yeah, it's an interesting thing. We're doing mostly on that side. It's mostly like JavaScript work on the front end, which is this kind of interesting thing it's got like a part of it that's a little bit like a React model. I guess it's technically like RxJS. They're doing for some of the state management. Like parts of it work like that. Other parts are just kind of straight jQuery. They've got their own like build packaging system that has this concept of like we're gonna break up all of our stuff into like every function and every object has its own little file, and then it all gets mangled up into a big deliverable package. Okay. Bismonger. You know, I am terrible with names. So no, that one's not jumping out. Attempt of Elm. Okay. Yeah, I think I remember some of that. Oh yeah, you had a really big app, or kind of big-ish app. Is that yeah? Uh, Big problems tend to have big solutions. All right, so that is switching based on which thing it was on. These are switching states. HTTP response has been somewhat condensed. We've still got a special case for fetch token. We sort of emulated the Elm's concept of expectations, but it does very specific strings. And HTTP expectation. Yeah, so we're doing the expectation on the receiving side. Elm does it on when you make the request. To do that, we would have to have some sort of structure to store that. I see incoming events. All the different state next steps. All of our HTTP requests. Where is our next step? Well, I was thinking we might be keeping some sort of sent request state. And then you would save your states there. And maybe we move on to something besides state. Well, I guess everything that's going to have a request, maybe that would turn into like a state transition. It'd be a little bit like pending requests, except we'd need to have some sort of concept of do we need to send. And right now, that is when we do this. So new event, retry. So I guess that could be kind of like the retry state. You could do some sort of needs initial request, needs retry request. Versus building, Yeah, I've never really gotten into language stuff. One time I had like the console, like the sort of dev console attached to a game, and I sort of tried to make it a Lisp-like language to allow more complicated stuff, but that was almost more fun than practicality. Oh, domain modeling? Huh. I mean, this is a bit more technical, so I'll be just kind of refactoring through it. If you actually had like project proposal type thing, you do a little bit of sort of major concept modeling, sort of in the discovery phase, which is like might be like a solid day's worth of work, depending on the size of the project. Yeah. You might have to do a little bit more as you got into implementing the various parts of it. And of course, yeah, that all scales with the size of it. You know, a lot of things are like, well, you've got a user model and a couple data models. Or maybe you've got a couple user models. You know, you've got admin, user. Maybe it's a two-party system, so you've got two kinds of users. And then they're all talking about a couple objects. So that's changing request type. Oh wait, so that. Oh yes, this is our 1-2 stage thing. So for that, we need to make a new request. Huh, that's actually not changing the retry flag. Well, retry was for unauth, and if it's a single series, that's fine. So I guess the simplest form of this would be to just sort of track what we think the state should be on a request going out, and see if we can change our state trend. Well, maybe we have to add to our state transmission first. Also fetch token. Do I need to generalize that first? Because that is an HTTP response, but it's going to be a different kind of thing. That does not have a state. We don't care about a particular session token because this is kind of an app level thing. Yeah, so all of these immediately try to decode state. Which implies that we have a state. If I want a generic HTTP response, I have to have it actually be generic. Well, I guess I could start with just this going through the generic path. And then try to work towards. This would also go through that loop somewhere. I just have to figure out how to state that request mapped to a token request versus a particular state. You might need to kind of reevaluate what a state is as part of that. So there's pending requests to make. I'm eventually going to need some stuff attached here. Just seeing that we got, well, yeah, if I'm going to have some sort of identifier attached to it. And I kind of have some ideas that you could do a sort of like a fact-based match. You know, oh, well, this one was sent with an ID, so we're going to look for the ID coming back. Although you still have to deal with the decoding and encoding in that state, although it'd be encoding and decoding less stuff. Perhaps. But you're not going to be a state. Actually, if it's a request, it's not just going to be, it's going to be kind of a dict. Let's see, init. Dict.empty, so that should at least compile. I don't do anything with it yet. So now here's the trick. Every time we do some kind of fetch, there's fetch token. Well, okay, so it all goes through execute request. That gives me a command. Is that the only place I use this? No. With all requests does a model command, but it only takes a state to command. Well, state is currently the thing we're storing here. Model pending requests. But this is used for things that are not HTTP requests. I might want to, there might be a place to have like a multi-level command thing at some point. I don't know that I'm at that point yet. However, in order to have execute request, modify our model, it has to do a model command message, which means every other thing that goes into the same place has to be a model command message. Which means this has to like break that out, update the model again. Oh no, I guess I could update pending requests before passing through. Oh, that means you have to be not just return a command message, you have to take the model in so you can modify the model. Okay, so that's the state. There's probably a place for the function that is just the command here to be its own thing. With our original signature and such. Because then we can just do model outstanding requests dict.insert model.outstanding requests. Our execute request does still change. So that means with all requests has to be able to handle that signature. So it's going to take a state model, model All right, so you are going to do all of that. You're going to do all of that. This that map f. The function needs the model. Oh, this is going to become a fold. Well, no, wait, I'm doing a dict.insert. What's my key? My key has something to do with my HTTP request, which is where it's going to get a little bit. So I'm not even necessarily ready to do this yet. Because somewhere we have to have a way to generate the IDs so we can actually make these. And we want that process kind of has to be working before we can insert things. And then you want to have like a function that would say, okay, here's the thing to insert into the model. So update the ID and do that. So once again, adding a field to the model, no big deal. And then we can sort of start to insert the process we're working on, which maybe this wouldn't be so bad. But the idea of we need to do more than just dict.insert eventually there. So execute request. So we're kind of back at the same place here. You need to update the model. Okay, that still matches. Just increment that number for now. We're just going to change all this stuff. And I think there will eventually be a way that we could perhaps move this outside of the main body of the code. But that would itself be a pretty big leap. Essentially, we would end up recording. We want to make a request. We want to do a thing that's going to require a response, and replace all the command types with a thing that included, all of our own little effects as options, in addition to send an Elm command. Then you have to have a wrapper around your update that would take all of those things and say, well, in this case, we're going to tweak that model some more to track the response. Now, interestingly enough, one of the things you keep in a request in regular Elm land is the message to send, and if that is wrapping update, then it would get back an HTTP response and well, I need two level messages too. Because it'd have to be kind of receiving all of the Lambda events and like kind of doing the translation. Maybe that's where subscriptions come in. Like the Lambda events would come in, and then it would search through the last results of subscriptions to see if any of them were actually requested. And if so, what message to translate it to? But then HTTP is actually storing the application message. So when you get that one, you can send it directly. And for the other stuff, you would have subscriptions. Hmm. Well, let's turn it into a command. I can't inspect it further. That's kind of hard to do in the small. I guess you could have certain chains of things that could result in HTTP operations. Well, we need the command and the state. Where else do we actually do? Hey, Miranthu, how's it going? Okay, so init, we don't actually do anything with. Update event, step. And then all of the Lambda things would issue commands as well. Pen state is just step. You're going to batch all those. You have our web requests. Uh-oh. Yeah, I've gotten to bed too late. I've had restless nights. I've had tired days, but I've never actually gotten my sleep schedule that far out. Yeah, I tend to vacillate between I need rest and, well, I'm gonna get up, and if my body doesn't like it, should have darn well gone to sleep. Maybe you'll do that next time. It's 5 p.m. Oof, yeah, that's a lot of work. Yeah, that's an awkward one. I mean, maybe you, like, get up to work to, like, I don't know, a reasonable late-ish time, midnight or whatever, and then see if you can kind of slide back in. Okay, so that's Lambda. That's calling error response, which is Lambda. So we can do Lambda commands. And we can do HTTP requests, which are Lambda commands. Actually, do I have any commands in this that are not just sending a Lambda? Or a Lambda command? Airport. Well, there's command batch. I might not. Ah, yep. The only thing we can do, really, and there might be some other things like, well, I won't really do time in this application, I don't think. Our Lambda commands, which are like decrypt an HTTP request. And I guess response. So rather than having those immediately call the ports, I could have some sort of abstraction where it's like, okay, here's a command sent to event. Needed hopefully response from the context and the event spotty. Yeah. Okay. Yeah. And I guess having a backup choice might give you a little bit of better negotiating ground too. It's still a bit of a brain burner. So if we had our own like Lambda command type that could be translated into a thing, that would allow me to have one like effect type for all the Lambda stuff, which would then be potentially inspectable. So actually, what is... So we've got decrypt takes a list, so that would be the data. Well, yeah, it's not the most popular thing. So Elm has this idea. Well, let's see, where do I start? There is a runtime system. The runtime system sends you messages and you send it commands. So it's a little bit of a black box there. The black box is running you. It's a framework. But within your world, it's pure functional. You keep your model, you update your model, you send it back to the framework, it returns it to you with your next message. So you've got this pure functional paradigm. And one of the challenges with that is that you do asynchronous communication with everything for the outside world. Some of the Elm libraries cheat that a little bit. And in your command, you can say, and here's the message to send me. But there's not really, but they're kind of cheating that. They're storing that like in JavaScript outside of your program state or something. If you want to have any kind of request response setup, not using that runtime system because that's all browser support and we're in Node. You essentially have to kind of keep some information in your model, which if you do the callback thing means storing functions in the model, which is also not recommended practice. So I'm just kind of looking at exactly how to do that. So the decrypt command would be a type with a list secret. HTTP request would have a whole bunch of stuff. So we'd actually want to pull this out as a request type. We've got our state value, which is what we're currently using to get that sort of request response matching. And wasn't there response? is how we do our final response to the Lambda event. So that would have a value and a result, which has another, potentially another value. But those are somewhat representable types still. You'd still have to have a thing that translated that custom type into actual commands. But if I had some sort of abstraction of these in the effect type, it would have the possibility to inspect them and reflect on them. If I just called these and stuck it into a regular command, then it would just be an Elm command, and that's an opaque thing. I don't think that's necessary. Well, no, where that would be useful would be the HTTP request. Because then I could assign it an ID. And pull out the response object or callback, save that, and that would give me an Elm-like thing. I guess the question is how... I'm trying to decide between going full into effect response types instead of commands, which we might kind of end up there anyway, versus doing more model updates in the meantime, and then maybe trying to refactor to that later. Yeah, I should probably be doing a straight implement. I keep leaning towards doing a straight implementation of it, and then refactoring towards the effect type thing, which puts us back at execute request, modifying our model, and for now, all we want to do so that we've got our state management, and then we do state command, and then this forces, what the heck did I press here? I don't know why this thing keeps launching. Sometimes it just launches itself. That forces the, well, with all requests does have a model. That forces this thing to pass the model to all of its functions. And it forces this to be a state model. Actually, with all requests, well, it's a state to blah, blah, blah. I could maybe rearrange that to take state as the last argument, but you're still going to have a thing that returns a model because it has to modify it. Oh, no, actually, if I want to do a map like this... Oh, you know what, actually, and this is where I was thinking, oh yeah, this has to be like a fold. What's their argument order for that? because potentially each of these is going to we could have multiple commands, each incrementing the state themselves. Fold L and fold right. I forget which one is supposed to be more efficient. Step 1, 2, 3. Normally you go from the head, so I think fold L is going to be the more efficient one because it's going to just pop off the head every time. So the function is a list of A and a B. So actually this does end up matching fold L. And it's going to be state model. Fold L, the function, the model, except... Yeah, that's going to get passed once. And then this is the command message, so it's the entire thing. Wait. That's model command message responses, though. It's not, now we're not. Now we have to keep track of all our commands. So the thing we're actually folding over has to be that. And this should probably even just make this a little function. I don't think there's really a name for the model command message thing. So from our perspective, we're going to get a type model command message. We're going to need the model somewhere. We're going to have a list of A's. And we're going to return a model command message. Does that work as a fold function? Right, as I was originally going to do this as a let block, which could directly use the function. So we take that as an input. fold L itself, so we kind of need this as a right signature to work as a fold function. So that's your B, that's your A. So this has to be our and the return value of this. We need to take this function in and return a function which does that type to that type. And technically this could be lowercase message because we don't really care what this is. We're not going to explicitly mention any messages here. And that's a type signature a mile long. Right, did I do too many of these? Yeah. I did do too many of these. Oh no, that was a missing parenthesis because we still have to pass the model, or the initial state. So model command message is going to be B. So you're just going to take, in practice, you're just going to take that, and then everything else is going to flow through. So we need to return a fold function. But how do I do that without actually manipulating the parameters? We're kind of back to a lambda thing, aren't we? No, that's the signature for foldo. We just need a ABB. Which actually might mean it goes to more like this. Where we do mention at least some of these and partially apply it. So in practice, this is going to be a state. But it's really just data. And then we've got our model command. So we have a function of a and model that gives us our new model command, but we have to put the commands together. And I'm not actually sure what the order is on those, and I think in practice it's not going to matter. And that's taking care of the command batch. And then all of the functions that go into U actually does with all requests itself, the rest of it does not change signature. So all our error response stuff, which error response is a lambda response. So these have to have that signature update, even though they don't make any state changes because they're not sending requests that need responses. Which would have been why you'd want to do the effect type thing. And then error response state. And there's one app where I had some things that helped with some of this, although eventually we're kind of hoping to take this back out. Okay, then you return that complete type. So when used directly, just a little bit different. Actually, so error response itself didn't actually go in there, but it got used in U. Oh, error response. So actually, this is the exact same thing. So maybe error response itself didn't need that. Yeah, okay. And then I think then this ends up calling it with the model that you got. Error response, though. Can I just do this? And I guess in practice, these weren't too bad. Okay, we have not sorted things out. That needs to be model. We still got an error response. It's taking a model somewhere. Oh, didn't remove the argument, whereas you do have an argument. Okay, so our fold's giving us trouble. I need to take a short break, though. I will be back in a minute. Yeah, we'll be able to see when I have hair now. These close? Okay. Oh, wow. I mean, I guess, yeah. I think, yeah.
Here comes the venerable Otto. Excited. Otto, do you have any words to say? All right. Everything's good. All the check marks are checked. So now we just need to open the door. Okay. Door's opening. Retract the gantry. I always forget to retract the gantry. And oh, nice. The fuel vented to space. So far everything worked. Here we go. T minus 3, 2, 1. Ah!
That's a long smoke break, boy.
Look at this, look at this. Are you blocking me off? Oh, this is funny. Alright, everybody got all their stuff? I haven't seen it in the chat. Can we farm with you? It's probably going to be up to Rye Guy. He's going to be the party leader. Back off my man, this guy.
He's standing there.
Oh, damn.
87. Goodness gracious.
Yeah, I've played him a bit.
Boosted.
Okay.
Yeah.
Nice.
Taking a hit now.
All right. All right. The second argument, a tuple of type. All right, so it's looking for a function of model to model there. Saying it expects model command. All right, so in the signature, it's looking for a B2B. Oh, this needs to be command fold F. That'll throw things off a little bit. Oh, okay. Not quite sure why things resolved exactly that way. Oh, that changed the argument list of fold to... Right. That would have left it with this and made that the type. Okay. Okay, so we still get a response. So this allowed us to keep a counter. And I got all the state stuff in place to do that. No, once again, I need to make sure that this update is centralized in a place. Okay, so it's an execute request right now. So that means you would also, well, you would let this ID and use it to both update the next request ID and to use that to insert the state. And then this would probably have to take the ID and like pass it down to this stuff somewhere. Lambda HTTP request. I might be able to flip this around to make this. Well, this isn't encoded yet. But the thing we pass to here be that ID. Other way to look at this would be to put the ID in the current request in the state itself. Then you would just look through the list. All right, so if these functions started taking the model, then they could, yeah, you have to allocate the ID, insert it. So we have that. We can build up our dictionary. But actually attaching that to the HTTP request. And maybe I just have an extra field for that for now. So we don't have to rewrite all the functions too much. And that should be compilable. Out. Why can we not? I've typoed the other one, I guess. Outstanding. And I completed the second copy of it. key value. It's compilable but not useful. So either I have to thread this through all the request stuff with the ID, or I have to modify all of my local fetch functions to take an ID instead of a state. Although, I still have to modify them to pass an ID through. So I'm modifying local fetch functions regardless. And ultimately I'm passing it through the lambda, but I could replace the state with the ID. What is matching on the other end going to look like? So we've got fetch token, which won't care about it. Oh, right. We're doing state as a completely generic thing right now. So it would be different for you. That's fine. We only use it here, so this decode state could turn into look it up in the dictionary. And that would save us the encode decode. We still have to deal with the not found aspect of it. So that makes your state value into int, which, since at the moment we're treating that as completely abstract, well, it's getting encoded one way or another. Just a question of where you encode it. So that seems to suggest that you should be ID. Did that be just an int? I can do a type alias. I mean, it's still a little loosey-goosey. It makes things a little bit easier. Well, it makes it more obvious what we're passing around. Oh, but I'm inspecting my state.request to decide what to do here. So you still need that. Fetch videos and company. Just need that to encode. It'd be nice if these things returned their own ID, but you need the state to keep that around. So then we'd have to have the model to have them update the model with what ID they used. Here's where the effect type might be useful. And maybe I need a better word than request ID. And then from here on out, should be all this stuff. So we're still a bit loose with the fact that that's an ID. Code.int, and I haven't dealt with coming back yet. Right. But since from the perspective of the type system, it's all just JSON values, it's not going to be a compiler error. So this is going to be, yeah, this only removes it. It does not remove and delete. You could, an update can do it, because it's maybe to maybe. So you can say, we're always going to return empty. Well, no, because I can't really have side effects while doing that. So we have to fetch it and we have to delete it as separate operations. HTTP error for state. I'm actually not sure why. Probably because of where their code used to be. HTTP expectation. Which the expectation is something we might want to be storing eventually. So that we can look it up and then call it. So the error in this case would be not found. And hey, what well, no, this is a result versus a maybe. So now instead of decoding it, do you even do model stuff here? You return the model, you pass it to update. But you normally don't do model transformations yourself, except that now it does. Oh, we do have to do for this, which itself can fail. Right, we did a handy little function for this. So this has to be a decode value. Yes, you're already a value, not a string, of a decode int, and that could fail. And then we need to look it up. And that could be there or it could be not. And if it's there, we need to have the ID to delete the ID. So I feel like we want to pass a model-to-model function to like an HTTP response. Type thing. I've already got an HTTP response. HTTP match. Expect. Okay, you're different. So you're going to take a value. You're going to take a function. Or are you just valued a model? And then we just kind of pipe that into the other function. No, because I need you to do a state. Or this thing goes to a maybe state. But it would be nice if it cleaned up the model as well, which means we have to modify the model. But right now we know all the state information. So I'm going to have to pull the state out. Either as some sort of lambda or as some kind of like maybe map. It says modifying the model. We also have to get a modified model out. This thing does not currently send messages itself. We could do it as that. But it's either that or we do like a pair of state model. If that is guaranteed to turn a response, you could do a let equals. And then in update. If it's a function, we're gonna have to do like lambda state to blah for both of them. State modified model is a better description of what it's doing. I guess this could technically be an A. Oh, and you need you need the model anyway. I just hadn't gotten there yet. Wrong way. So this has to be a decode value of a decode int. That's an ID. If that is successful, that is successfully parsed, maybe this would start to make more sense as a result chain. Because we do the code. And if that works, we have to do, well, that's going to pivot to a maybe on the lookup. Now you get the state. And then we have to have a function that modified the model to do this. Oh, no. That's your model update. There's your state. Yeah, I don't know of anything that would be Give me the value and remove it. Oh, it's remove, not delete. I mean, I guess I could write a little function that did something like that. This is probably a little bit more of an ordinary error, but that means we have to start dealing with maybes here. I guess that could start to be considered an HTTP error. And again, what the heck would Elm even do if that was the case? Unmatched request. So this would turn into HTTP match. Modified model. Maybe the expression between case. Above Seagull, thank you for the follow. Don't you like watching me get puzzled? Okay, stitch.get. Is stitch.get not a maybe? Comparable? Did comparable maybe? Did I? Oh, I forgot the actual. Why don't you pass the dictionary? I probably didn't pass the model into it. Yeah. Nice. Yeah, I'm doing extra hard challenge mode right now. Trying to wrap my head around doing things without a lot of the standard Elm libraries. Of course, I haven't seen if this actually can process requests. Yeah, it was more. Well, there was definitely some weird callback juggling in the straight up JavaScript version of this, but I mean, it would have strictly been quite a few lines less code. It's really just I was curious about what things do look like without the standard library stuff and what they might be doing behind the scenes to make it all just kind of magically work. Okay, the simple case worked. How about the multi-step one? Okay. And what this saves us is state encode and decode. I think we wouldn't need those anymore. I might keep this around. The request decoder I might want to end up reusing, depending on how I feel about the results of stuff. However, I think we do not in fact need that right now. So the one weird thing I've got going on now is that I'm doing some HTTP requests that use this outstanding request system and some that don't. The main thing this saves us is encoding and decoding a bunch of stuff to sort of pass back and forth over the ports. So if I wanted to generalize this to an HTTP request system, I'd have to do something with fetch token. Yeah, I kind of stopped streaming it because there wasn't a whole lot of people hanging out, but well, it was kind of my winter exercise program, and I haven't had as many places to go on my bike in the current conditions. I mean, weather has been getting better, but I haven't really had, there hasn't been a farmer's market to go to. So possibly on some days I should still just go out for a ride anyway. Yeah. There's a pad behind the curtain back there. SDVX. I'm not familiar with. I mean, there's a whole bunch of variations. Beat Saber. Music games. Oh. Okay, so it's a different branch of Konami stuff. Which looks an awful lot like, well, there's something up there. Okay, so there are various. There's not just the four things. No actual screenshots. Knobs for spinning. Okay. Oh, is this just the music? Yeah. Yeah, sure. Hmm. Ah. Complete with keys. That is, did I have this on? No, I didn't leave playback speed up. That is insane. So it looks like the knobs are essentially the outer lanes. And I guess there was something else that's the FX button. Oh no. Those are like two different positions. Okay. Oh, and I guess FX is the yellow thing. Shh. Yeah, the four buttons almost looks like they took a DDR and then tried to make it more of a hand game. Maybe when it first started at some point before a lot of iteration. Then again, I guess 2 per hand is kind of a natural breakdown too. All right, we are committed. Yeah, I guess the one weird thing about my Step Mania is that I did a bunch of Lua code for a custom theme that just kind of picks songs and tries to do it in sort of a warm-up, cool-down, middle kind of thing. And I and I messed around a bit with linear regression to try and estimate scores for songs I haven't played in order to fit them in appropriately. It's not really a theme. It's like one screen that does all the picking, and it's kind of ugly. I never spent a whole lot of time on it. So I think this one actually behaves a bit better in windowed mode. Outfox is still pretty much full screen only. Of course, it's assuming I left it in windowed mode. Okay, cool. Well, it still blanks the screen. So that's the linear regression bootstrapping. There's a curve to it right now that I've never quite dug into why that happens. Huh. And then that's the curve. I haven't been super happy with it right now. But I mean, those are like the only 2 screens that are really part of it, and then a few settings that are just overlaid on stuff. And the code behind it could probably do with a total rewrite, because I was learning everything. It's all in one big file, which that kind of seems to be just how the Stepmania stuff goes. I don't know. I've seen some ways to break it down, but I haven't seen good ways to break it down. Well, yeah, for me it was like I would tend to like start at the same place, and then those songs might get played in more of a warm-up level, and then I would kind of go up, and then I'd cool down and around the same place. And generally the easiest thing to do was, play them all in order, so it's always the same order. So this tries to prefer songs that haven't been played recently, and then add some randomness on top of that, so that doesn't become its own pattern. Yeah, I did that. I found a thing called Drunken Shame that was like just play songs randomly, like super, super simple. I found that its auto adjustment kept things way too slow for me, though. Not really, unless that's the crazy ones. That like send stuff all over the place. Yeah, so I've had to move a few songs around. I don't even know if I could select that here. It's like I've got a song pick, but the score is probably so ridiculously low it will never select it. No, not theme options. Skip default. Where would that put that? A 4, huh? Yeah, this is... I couldn't read it. It's like, I don't even know what I'm doing. And it hasn't even gotten bad yet. Yeah. What was that display? Yeah, I mean, it's probably fun if you've like memorized the steps, but I just don't play that way. I mean, it's pretty. I don't know if it's playable. Yeah, I don't even know how you sight read that with the directions changing. I mean, I have enough trouble with sight reading when the notes get close. Mm-hmm. So to generalize this system, we have to get this thing into the system. One way to do that would be to make the thing we store the callback function rather than the actual state. Which would put my HTTP expectation at a different level. So HTTP expectation we were putting that into decode response. So you take the response, you decode it, given an expectation. So the expectation is in fact probably what it would store. The decode, given an expect. If we store the expect instead of passing it there. So I was kind of building towards this. This was based on the tag. This would be, we would just kind of put this in line when we make the request. Next, request ID. So this is storing the state. We would change that. HTTP expectation, my HTTP expectations takes the state, so that would end up storing it. And we could have different kinds of expectations that didn't encode states. Well, my HTTP response. Oh, this is just a general way of pulling out the errors. Right now, my success takes a state. And that's the other HTTP response. Name overloading. And then we've got like this message, which these things take states, so... But I couldn't query these before because the state was actually kind of coming back on the HTTP request. So if we save our state by wrapping this message around it, oh, you also have the decoder. Well, we're making an expectation that handles that. So our HTTP response, well, for what we're doing here, I think we could perhaps flip that around. So we could do this as oh, that's why I needed it. Because my error was telling me what to do when I got the error. Well, expect JSON. This is specific to this version. Might still be able to abstract that. So that would make an outstanding request a dict int to an expect message. Oh, you were just getting the state before, so you're gonna have to do different stuff. And then this thing was very abstract. It could operate at a very high level. So I'm almost going to have to return a different request structure here. Well, that's the one we're not dealing with just yet. So you only care about those fields. I also need an expect out of this. I could have these return two things. I could have them return some higher level structure. Which, okay. So I guess, step one is get these to return that. And we'll just ignore it for now. So in Elmland, we include that as part of this stuff, and maybe there'll be room to have that sort of intermediary request at a later time. Indeed, I could. Well, I could store this entire thing, except I kind of don't want to store this entire thing because it's got the keys and the headers. So I've got a command. To make this most like Elm, it would have our own little request function that took these things plus the expectation. And then we would pull out all the fields into a command. And that could handle this step all the time. So that would return some sort of request thing. These things would not have to deal with the request ID. They would need all the parameters to make the expectation. What would that look like? Well, this would actually be taking something like that. So I'd have to either make a type for this, which we will be returning it from those functions. Well, no, we'll be passing our request structure into one function. And then we'll have to pass that to something else, so we kind of might want to type it. I think even the Elm library uses string for the method. And we do some stuff with headers, which has been an array of lambda headers so far. And then we're going to have to add some stuff to that, but so you're also going to return that. Oh, so you're going to take all the parameters that we need. Including the expectation? So we have one function we call that returns, yeah. So I might actually want to type the Lambda request now if I'm going to be doing other functions that generate them and talk about them. For the one function, it was kind of okay to be loose with it. Lambda.header. Oh, it's a regular old thing here. An HTTP request. We're going to pass something with more than this. I eventually may not need tags because we're going to have that may take the place of that. What does the standard library do it? He calls it an expect. Although I think that they are type, yeah. And I do expect message. These might not be as picky, but they might. All right. As we pass that from the source. You do an HTTP request. Actually, you're just going to return a struct, and then the type of those functions is going to be this. I mean, I guess I could still have a wrapper around it in case I need to do further processing. But for now, it might be that. Okay, we'll leave you alone because you're still doing that differently. If we convert these to do that, oh, what we need, the interim step. So you have make a request, and then so you would either be a function of ID to command, or return a function of ID to command, or we keep it around as some kind of request object, and then we translate it to a Lambda request at a later time. Which would be something like actually, you might end up being specified because most places I'm going to use this are going to be passing a specific message. And then you are going to need the request ID. So that's when we have to supply that. At this request, we'll have the expectation, which could be potentially be used elsewhere. I mean, this is almost when we should generate the ID, but we have to do that in model. Or maybe this thing ends up being, takes a model and returns the updated thing. Neo. I probably could have worked this out. We've changed our type signatures. In a more or less no-op manner. I don't know if that's worth doing at this point. All right, so you're the special case for the time being. Oh, this is going to require a expectation. Maybe we leave that out while we do the rest of this stuff. And then that takes the ID out of you. You are not returning a command directly, returning HTTP request. Although I could do these kind of inline by saying, okay, take that and then throw it into Lambda. Doesn't really, I mean, it does a little bit of transformation. I guess it's the baby step thing. All right, so that's your expectation. So this is a state command. It comes an HTTP request. It doesn't need the ID. So it's not even a state command. This is a state request at this point. I mean, I think we'll need to do more with this later. But for now, we can go to a Lambda request. I probably didn't do this in the right argument order. Oh, there's like 2 Lambda requests. Yes. Okay, I didn't change all of these. I think I changed at least one of them. Yeah. All right. Can I get you the parameters you would need to make this? Expection? Oops. So the tag will be implicit in each of these. HTTP response at this time still needs state because of error messages. I mean, we could maybe move these things up to having it incorporated just to step towards that. Sure. You... Right. So we actually need to have the type available for this. We just don't use it yet. I stopped passing state through here. But in our present scenario, we need to have that to build our expectations. And maybe... Right, that will eventually end up in the tagging message to tell us which thing we're responding to. And maybe I can eventually do something where the message is using this stuff instead of the state. Although I have to track my retries somewhere. And all these calls have to be updated. No, this is the wrong call. This has state. An HTTP request has that. Is an unbound type oh, so this would have to be HTTP request message to be able to handle expect message. And then you don't really type your arguments. Some of those functions might not be using a type per se. Well, this is our internal type, so that's fine. Okay, so we did not add that. We did not add that to the actual. Oh, I added it to you. I didn't add it. Okay, I added it to you. I didn't add it to you. So that compiles. We're not using it anywhere, but it compiles. So then, so that was inserting state. Have I actually updated my response to be able to use its internal state? Expect JSON, HTTP response. So this should be making a thing. Where we provided the state, the source, the success. The result gets provided later. So that would include our state value. Where do we do our lookup? HTTP match. So that would be just an expectation. So this would return our expectation rather than our state value. And these would collapse. Because you'd be providing a result. And HTTP response in lowercase. So right now you get a success. Which is our tagging function with a value, which case result. So that only happens on the successful response. So on the successful response, we would do decode response with the expect. And the body, and we, can we do that as, well, HTTP response should already be handling the result error. Yeah, what are we passing in here? We've got body, expectation, Oh, decode is string. Did I never complete putting the decoder in here? Because you're tagger. Maybe I was so wrapped up in other stuff I didn't actually have you do... And yet everything's been working. Where do we actually run a decoder? So expect JSON returns an expect JSON with a function that runs decode string on. So yeah, we're applying this function. It's not just a tagger. This is almost decode string. The tagger is itself result. And then where are we washing out result? So you're the tagger. You are maybe not a tagger. I'm like a decoder tagger. So that's still a result. The decode response goes into the expectation. The expectation we're giving it is HTTP response, which is handling success or failure. Decode response. So that is doing the JSON decoding of the response. Sort of indirectly. It is running the expectation, I guess. Maybe decode response is the wrong name for that. Well, one of the things it's doing is running a decoder. So we would have the matched expectation, the body, and this would translate to the message we wanted to send. Okay, so this is what we're doing right now is the okay we got a body, the error we didn't get a body. Decode response is currently taking a yes, we definitely got a body, and applying the expectation to it. I think expect error is explicitly because we used to do this thing where we were decoding a string, we had to have some way to represent that. So when this is done, that function will be gone, and that will not actually be a possibility anymore. At which point, this could take a response or a result and it would do a different kind of switch. Well, it would be two levels of switching. So we've still got to deal with this. But don't we map a result somewhere? Maybe HTTP response is only mapping decode errors? HTTP error. Which my HTTP error, I believe, includes bad body as a possibility. Result map error, so that takes a decode error to an HTTP error. It takes everything of a result HTTP error as the tagger, which is the HTTP response function. String state result HTTP error A to message. So I might need to do an HTTP error upgrade. So lambda HTTP response. Is a lambda HTTP error. Okay, so I've already got a my error, which we're using in fetch token and okay, so we're mapping the my error here. Oh. So I don't actually use the expectation here? I would still need to delete it, so I might want to do a lookup and delete. But I'm wondering if I should be compressing like this match process and the run expectation process. HTTP state value model. So you're not doing anything with the actual response. You're just looking up the expectation. And you're looking up a state value. Okay, decode the int, got an ID, look up. So that would be look up the expectation. So we look that up, but we also have if we found it, we have to delete it. But if the response, the HTTP, was one of the lambda errors, to do an Elm-like thing, we would run the expectation with our HTTP error, because the message inside takes a result HTTP error. So do a map expect message expect error So this would have to take a result. Now you see, I've typed this. I thought I typed this. You're applying the decode tagger to body. Decode.decode string decoder. But the thing we're feeding in here expects... Okay, that's an HTTP error. So maybe this whole thing... An expect message. Rather than being... applied to a value, needs to be mapped on a result. So we're returning a function. Maybe it's expect message. Ah, now you see this is, yeah, this is string to message. Well, the expect type we probably don't get to see the internals of. Expect JSON takes a result, it's a decoder. Got GIF is a result. So we're giving this thing the same kind of argument. We've got a higher level processing that deals with the errors. So this is a function that takes a string that we're processing. So to apply the actual response to this, this would have to be a... Well, I guess it'd technically be a lambda, wouldn't it? But I could map the error. I could do a map error on the response first. So this is good because we can just do type check on this transformation. So we have a function that takes a result, and if it is a body, applies that to it. But the outer is going to be that. A result and then only works on successful? If it's value, callback, otherwise we keep it. It's the function that returns another result. So the code string, we map that to an HTTP error so that it maps in with the existing thing. So unfortunately, you can't get a nice little pipeline out of it anymore. And then we pass that to the tagger, which is an HTTP error. So those types should match there. But we go to code response. You are not a string. You are a result HTTP error string. So take an HTTP response. We would do a map error, my error. And then that error ought to be able to fall out from the embedded state in the thing. So we'll probably complain about previously handled cases. Okay. Okay, so that does that. Let's do a simpler query. I don't have good reporting about where that's coming back at. Could that be decrypt error, request response, else raw data? Well, it doesn't look like a raw data. That would be a 404 though. No, fetch user by name. Ah, so it just returns an empty response is what it did. It's okay. However, that is not an HTTP error. I must have not compiled yet. Error not found. So that would probably be from the JavaScript, and then HTTP error. Came in on HTTP error. Good. Okay, so that handles most of them in one spot. And then we're not actually, we're passing it to expectation, but the expectation is what we expect to eventually get from what we store. So we have made a bunch of changes leading up to this. Put in the explicit tag, although this function will hopefully go away. We abstracted that in preparation for pulling out the expectation to save it. Swapped these around to have expectations. So HTTP match may still sort of do a thing, except it's going to give you an expect. And that's going to fill in there. Dict.get outstanding requests is going to be an expect. Dict.remove is fine. Well, except I'm calling it a state. And then you're inserting state, where it would be rec.expect. The state is getting put into here, so it goes into the actual request. Okay. That wasn't as big a deal as I was afraid of. Now that we've got this down to one call, I'm not actually using... If I get rid of fetch token, I may not be using that. I guess I missed the compile. What I was wondering was, would this kind of turn into one function? You're just returning the expectation. I could have it return the message. Run the decode response. If given a result, well, definitely has to modify the model. It has to have the state value that came through, which might I might need to move state to a message specific thing. So there's going to be an HTTP response ID and new session is going to have its specific thing. That's more like an execute expectation. So here's another funny thing. Expect JSON is a result. Well, there's still an expect string implied there. Full Elm has an expect bytes. So maybe there'd be a little bit of a difference between those two. But it sounds like expect JSON actually is effectively an expect string that applies the decoder to it. And an expect string version would just apply the tagger to the string, or to the result. Because, I mean, that's a result string. Do I even care what type you are? Well, expect JSON, or expect string, has a result string to message. So if we're going to apply that, yeah, so this might be where there's some standard library magic. Because you would have to get a different response if we got bytes versus got strings. Or a different result type. Now your message, your variable message, this could probably be variable in message. String, I think, gets entailed by expect string. We're wanting a specific type of result. Maybe if this had like an expect bytes, then this, well, it wouldn't be any. It would be string or bytes. So that would be a little bit weird. Oop. Now this used to have the HTTP error case, which may have made it message specific. In theory, that allows us to handle fetch token. Fetch token env. So you're not going to do HTTP response, because HTTP response implies a state, which is something I might want to work on separately. I think you do expect a JSON. I've got a got token, right? Which you do accept a result because we handle that outside. So you don't do that. And what are you doing? You're a decode string, decode token. Oh. Decode token is doing some of it. We're turning that into a maybe, an okay maybe. Because that's probably a JSON decode error. Well, decode token would be our decoder. So you wouldn't be a maybe per se. You would be a success or a failure, and we could get a bad body. Oh, and fetch token was like an entirely different request, type of request. Actually, I may have to wrap some extra stuff around that to make it work. We did this, and we don't have that. So we actually have to do a separate step to send this. So right now, yeah, I forgot about a few things here. We've got state request, which goes through execute request. So we've got two Lambda requests, but that is given the ID. So this, is this what I was thinking of sticking into my HTTP request wrapper? Well, it would have to be model command. So for execute request, we actually want to get something like, I already got HTTP request. We think you get all of your information, you have auth, you have state. You're going to be whatever this is. Which I think is just this. So assign the ID, save the expectation, and pass it off to Lambda. Then fetch token. If it's like the other ones, does this. You'd have to deal with model stuff. Oh, actually, you have to deal with model stuff. It actually makes me wonder if the model-to-model message thing makes me, or model command, makes me wonder if I could just essentially treat this as a pass through the update function. Because, I mean, we are doing model transformations here. But if we were calling update, we'd still have to have the model, so. So your fetch token env, and that becomes a model update when we no, that would be more like and I still have to parenthesize it. Okay, we run a big request, multi-step. Isn't too bad as long as we're not fetching multiple tokens. All right, so that reduces all HTTP responses to a single code path. We're storing functions in our model. You could perhaps abstract the cases where you want to do that to some sort of enumerated type that stored just the basic facts, if you really wanted to get rid of the functions. And we don't need tags at this level anymore. All right, so my HTTP requests definitely don't need this. Lambda HTTP requests, well, we've got several places to take this out. You don't have any place to report that to. Your HTTP request, so you're encoding that. Well, maybe if I need to report errors in here. Request response. Bad status. Now that's a body. HTTP response string. Now this might want to turn into the ID, and we stop handling that as a state. Because everywhere that we've got the tag in here is where we'd be tracking that. Or we've got the state value. HTTP request message.state message.request. We could actually just put that into our request structure then. Actually, this is that state and tag. Tag was in the structure. So you would be able to return this directly without encoding. HTTP response. HTTP response, HTTP response. HTTP request. So we would convert this. That's going to make everything all kinds of upset. Tag equals ID equals ID. Not going to throw that away just yet. Right, I just took it out of here. So HTTP match doesn't need to do the decode anymore. We don't have to worry about a parsing error. Okay, I typoed that. I mean, I could do a little alias decoder for that. All right. And then maybe some of that mechanics could move into here. So if we remove the tag, we've explicitly done that. HTTP request takes a value. Now there was the event state. State decoder. Yeah. Of course, this is only handle HTTP requests. If I have any other sort of semi-synchronous request-response thing, well, this is a generic method. It didn't need to be a generic method. Okay, good. So that removes http.tag. I've removed it from the structures. Yes. And Jingtron, thank you for the follow. I think that means I'm in handler. I could move the request ID type up, although if you're doing next, you'd have to... No, it's an int, I guess. Could we do something like HTTP state? Well, baby steps. So remember is a one-step operation. Find and delete is a one-step operation. So if instead of model, it was like HTTP state. Now this is also taking my internal HTTP request and doing the translation on it. And we're using rec.expect. Well, the only thing that's different here is the expect. So if we made that our lambda type, and our HTTP request just didn't encode that field. We've got two directions to go here. We've got, and I might be kind of hitting lunchtime here. We've got remove generic state from Lambda interface, and we've got encapsulate HTTP responses. It seems like the ID is probably the definition of ID belongs over there. Then you could have like a next operation, but really the outer world doesn't care about IDs. We need to have some HTTP state. Well, we're still handling that through Lambda events. In order to remove something from the queue, you'd have to pass your model to the thing that's removing it from the queue. So that doesn't quite work. So ID still has to come back through the messages. But then maybe you could do a wrapper program thing. And I don't know if I'm super clear on doing either of these things right now. But that's going to be some wrapping, some function moving. A step on lambda would be to get, because the only time we really used the state response thing was actually on HTTP. And I guess I could just put in a null there to do the event state thing. The other place it came through, where's my event decoder? Was on lambda event. So that would just give new event that field. And then, yeah, this was a map to into an event state. So basically we'd get rid of event state. Is this doable? State. Yeah, everything handled state, even though it didn't necessarily need to. And that's commands. Exports.handler. So let's update that so we can get it. Then in our lambda event, new event, event state. Okay, so we had a alias for state. So this is, maybe we should have an alias for session. Wait, new event is actually a value? Right, because I was trying to keep this part of it semi-generic. So I wouldn't care about the specifics of what messages the application was receiving. And then handler needs to get that. The thing we passed through here. Wait, really? Event state, update. That's my new event. Okay, so that includes that's a different state. This is why this gets confusing. So Lambda event is actually handle, right? Lambda event, that's lambda.new event. So you get a data and a session. And then nothing uses state value. State for event. Lambda. Actually, we didn't really. We didn't really import any lambda anything. However, that need to be exposed. Error response. Okay, yes. And there might be some other places I could use that value. State.session. Send response. I mean, they're aliases, so it's not going to make any big difference in actual type checking. Of course, I got a little state module, so I don't know if I want that to import lambda session. The whole port module thing. Lambda elm. Decode event. Encode header. HTTP request. That was the state value, which, if it was state, it should have been this. Response. Error response. Success response. Handler, we were lazy about tagging it. Update event. All right, so now an update event, it's a lambda event, so it is a slightly different type. It doesn't have the state pullout. But it might be nice to have as a separate function. So now we don't have event state. Handle is a subscription to lambda.event. It's a decode event. event state decoder. Which just kind of falls down to event decoder? We've got event. Lambda does not expose an event variable. Oh, that was doing the decode on it. As a little constructor. All right. Lambda.elm state decoder. All right, so that's all the things encoding it. And actually, it's down to just HTTP requests now. So it's like we weren't even passing it to decrypt. Okay, so you are stateless. Lambda HTTP request. I guess if I had to decrypt multiple values, but I think I'm decrypting the pair, so that's not really an issue. All right, so we could potentially move that into some kind of HTTP state as a step. And maybe look at the wrapper application or effect. Oh. That's a possibility too. kind of part of the wrapper application. So that might be able to save us some of the model updates in our main app. We would just say what we want to do and let the higher level thing do it. And we might even be able to do a bit of that just in our own update. We have one update that returns effects and then a higher level update that interprets those. And that wouldn't actually require the wrapper application. It would just kind of be an abstraction of who's making those updates. Well, that's it for now. It should be well past lunchtime for me. So thanks to the support from the subscribers. Thanks to everybody who hosted me. Let's see. There's been a bunch of 1 hour on live stuff. That'll be Saturday morning. So I'd expect to be back on this on Monday morning. This is when I'm usually on. And I guess I went a little bit later when I actually was doing the Stepmania stuff. But bye-bye.